Something just passed through our solar system, and it's talking to us, not with words, but with radio waves that shouldn't exist. MeerKAT, one of the most powerful radio telescope arrays on Earth, picked up electromagnetic emissions from an object that doesn't belong here. An interstellar comet, designated 3I Atlas, traveling from a star system we can't even identify, is broadcasting signals across space. This isn't science fiction. This is happening right now, and astronomers are scrambling to understand what they're hearing before this cosmic visitor disappears into the darkness forever. We've only confirmed 2 interstellar objects before this one. The first, Oumuamua, sparked debates that still rage today about whether it was a comet, an asteroid, or something else entirely. The second, Borisov, behaved exactly like comets we know, almost boringly normal by comparison. But 3I Atlas? It's rewriting the rulebook. Radio frequency emissions from comets are so rare that most astronomers go their entire careers without detecting them. From an interstellar comet? That's never happened before. Whatever is causing these signals reveals something profound about the object's composition, its origin, and possibly the alien star system that birthed it billions of years ago. The clock is ticking. Every day, 3I Atlas speeds further from our sun, and the signals grow weaker. MeerKAT wasn't looking for 3I Atlas when it found the emissions. The South African Radio Telescope Array, consisting of 64 satellite dishes working in perfect synchronization, was conducting a routine survey of the southern sky. Then, the instruments registered something unexpected. A radio frequency signature coming from coordinates that matched the comet's predicted position. The team double-checked the data, thinking it might be interference, a satellite, or equipment malfunction. It wasn't. The signal moved with the comet, consistent and unmistakable. Radio telescopes detect the universe differently than optical telescopes. While normal telescopes capture light, radio arrays pick up electromagnetic radiation at longer wavelengths. This allows them to see through dust clouds, detect cold gas, and identify processes invisible to the human eye. Comets usually reveal themselves through reflected sunlight and the dust tails that stream behind them. They're visual spectacles. Radio emissions require something more energetic happening, something generating electromagnetic activity on a scale most comets never achieve. The MeerKAT detection means 3I Atlas isn't just passively drifting through space. Something about it is electrically active. Either the comet's interaction with the solar wind is creating ionized gas that emits at radio frequencies, or something internal to the object is generating these signals. Both possibilities are fascinating. Both raise questions that challenge what we thought we knew about comets from other star systems. Think about what this means. This object formed around a completely different sun, in a planetary system with different chemistry, different temperatures, and different evolutionary history. It carries the fingerprint of alien stellar conditions. And now it's close enough that we can listen to it, that we can analyze the electromagnetic whispers of another world. But the window won't stay open forever. Radio emissions from comets require specific conditions. You need ionized particles, you need magnetic fields or electrical activity, and you need energy. Normally, when comets emit at radio frequencies, it's because of processes involving their interaction with the solar wind, the stream of charged particles flowing outward from the sun. As this plasma collides with the comet's coma, the expanding cloud of gas and dust around the nucleus, it can create shock waves and ionization that generate electromagnetic radiation. But 3I Atlas is already moving away from the sun. It passed perihelion, and it's heading back into interstellar space. The solar-wind interaction should be weakening, not strengthening. Yet the radio signals persist, strong enough for MeerKAT to detect them clearly. That's the mystery. Something about this comet maintains electromagnetic activity even as it retreats from our star. One theory focuses on the comet's composition. Different star systems have different elemental abundances. The cloud of gas and dust that formed 3I Atlas billions of years ago might have contained higher concentrations of certain elements than comets native to our solar system. If the comet is rich in sodium, potassium, or other easily ionized materials, the vaporization of these substances could create a more electrically active coma than expected. The radio emissions would be a byproduct of this unusual chemistry. Another possibility involves the comet's nucleus itself. Some researchers speculate that 3I Atlas might possess an internal magnetic field, something incredibly rare for comets. If the nucleus contains magnetic minerals in sufficient concentration, and if the object is rotating, it could generate a weak magnetosphere. The interaction between this field and the ionized gas in the coma could produce the radio frequency signatures MeerKAT is detecting. Proving this theory requires data we don't yet have, but the implications would be extraordinary. There's also a more unsettling option that a few scientists have quietly mentioned. What if the emissions aren't natural at all? Now, before you jump to conclusions about alien spacecraft, understand that artificial in this context could mean something far less dramatic. Could there be some unknown physical process? Some interaction of particles and fields that our current models don't account for? Could 3I Atlas be showing us physics we haven't seen before simply because we've never had an interstellar comet close enough to study in detail? The answer might expand our understanding of how matter behaves in extreme conditions. The debate continues, but everyone agrees on one thing. Whatever is causing these emissions, it's teaching us something new. When Oumuamua tumbled through our solar system in 2017, it broke astronomy. The object's extreme elongated shape, its mysterious acceleration away from the sun, and its complete lack of a visible coma sparked arguments that persist to this day. Some scientists insisted it was a comet with unusual properties. Others claimed it was an asteroid. A few high-profile researchers even suggested it could be artificial, a piece of alien technology. The lack of radio emissions actually worked against the artificial hypothesis, but the object's strangeness remained unexplained. Oumuamua taught us that interstellar objects don't necessarily follow the rules of solar system natives. It challenged assumptions and revealed how little we actually understand about the diversity of objects drifting through our galaxy. But it also frustrated scientists because it was discovered late, when it was already leaving. Observations were limited, rushed, and incomplete. By the time astronomers realized what they were looking at, the object was already too far away for detailed study. Then came 2I Borisov in 2019, and it was almost a relief. This interstellar visitor behaved exactly like comets we've known for centuries. It had a bright coma, a visible tail, and spectroscopic analysis revealed familiar molecules like water and carbon monoxide. It followed predictable physics, and it didn't accelerate mysteriously or reflect light in weird ways. Borisov proved that not every interstellar object needed to be bizarre. Some alien worlds are similar to our own. 3I Atlas sits somewhere between these extremes. Visually, it looks like a comet. It has the expected tail, the fuzzy coma, the behavior of vaporizing ices. In that sense, it's more Borisov than Oumuamua, but the radio emissions push it into new territory. Neither of the previous interstellar visitors exhibited this characteristic. Neither one gave us the opportunity to study electromagnetic activity from an object born around another star. What this tells us is that interstellar space is more diverse than we imagined. Each object that passes through our solar system reveals new variations, new possibilities, new questions. If we've seen 3 interstellar visitors, and all 3 were different in significant ways, how many more types are out there? How many strange and wonderful variants of cosmic debris wander between the stars, invisible until they happen to pass close enough for us to notice? The sample size is growing, but it's still painfully small. A shift to blue light. Even more intriguing is the comet's change in color. Images reveal a distinctly bluish hue, a clue that gases, not just dust, are driving the brightening. This points to volatile materials such as cyanogen or ammonia being released as solar heat intensifies. Earlier observations had shown the comet's dust to be reddish, making this shift especially unusual and hinting at fresh material being exposed or new chemical reactions taking place on its surface. What might be powering the surge? No one yet knows exactly what's causing the outburst. Scientists suspect it could be tied to the comet's composition, perhaps containing unusually volatile ices, or to stresses from its high-speed entry into the inner solar system. Another possibility is that the object's long journey through interstellar space has altered its outer layers, setting the stage for the explosive brightening seen now. As 3I Atlas emerges from behind the Sun in November and December, astronomers on Earth will finally have a chance to observe this spectacular and mysterious traveler up close and perhaps uncover the secret behind its extraordinary glow.